What if you couldn't read? How would you perceive words if reading wasn't possible? For anything you encountered with words, you would just see a series of symbols with no meaning or purpose. In fact, humans are not meant to read. Our brains did not evolve for reading. Our brains are extraordinarily organized from the time we are very young for speech processing. The same is true for our vision. Reading, on the other hand, is not innate and requires the collective activity of many areas of our brain. Babies already have a sophisticated spoken language and visual system, but to learn to read, our brains must be trained to connect our visual system with our spoken language system, actually changing the way our brain codes phonemes and connects those sounds to meaning. We know this because researchers have used imaging techniques to show what actually happens inside the different parts of the brain when a person reads. When we read the word ingredients, for example, it activates the occipital lobe in the back of our brain in the same way any other visual stimuli would. This visual area in the brain instantly analyzes the visual features of the word. From here, it quickly moves into an area that cognitive neuroscientist Dr. Stanislaus Dehaene calls the brain's letterbox, or visual word form area. This is where we store our knowledge of letters, recognize single letters, letter combinations, whole words, and acquire the knowledge of patterns of the written system of a language. Scientists have measured the activity in brains of literate and illiterate subjects and detected brain activity in various parts of the brain that are changed by learning to read. Brain scans confirm the letterbox is only activated in people who have learned to read, and it will only activate for the known letters in direct proportion to reading scores. When we learn an alphabetic language, we change the way our brain codes the sounds of speech, attributing these phonemes to different letters. This process literally changes the neurological processing that happens in the visual cortex in our brain. But it doesn't stop there. Learning to read requires first recognizing the letters and how they combine into written words in the letterbox area, and then connecting them to the coding for speech sounds. Reading and comprehension is achieved most efficiently by first teaching letter-sound correspondences. Consider the word ingredients from our recipe. The word is associated with its meaning in the temporal lobe. At the same time, the brain detects the sounds needed to say the word. Once a child can recognize letter-sound correspondences, the anatomy of the brain changes and creates a whole new modality for language input. The child can identify words and recognize them auditorily to then access their meaning. This process develops yet a second route to support reading, going from vision to meaning. Hence, the idea that there are two routes of reading is a critical piece of all models of the process of reading.